All right, moving on to example number 7. This one works exactly the same way as example 6, believe it or not. Yes, it's a little bit more complicated, but you're still using the product rule implicitly. Okay, so first thing to do before we get started is put some parentheses around all your y's. It reminds you to use the chain rule. All right, first step of all of this, aside from putting parentheses, is derive both sides. So derive the first term, you get 3x squared, because duh. Now the second term requires the product rule because we have this function minus 2x here times y, and y is a function of x. So we need to use the product rule. So to use the product rule, we derive the first one, the purple one, that gives us minus 2, and we multiply by the second one. We do not change the second one. Then we subtract, or rather, add, rather, but in this case it'll be subtract because their next term is 2x minus 2x times the derivative of y. In this case is going to be y prime. Sound good? So that handles the second term. Now we need to deal with this third term here, another product rule. Okay, so we have this x squared function times this y squared function next door. So what we do is we derive the first. So we have 2x, leave the second one alone for the time being. Then we add on, leave the first alone, and then derive the second. So to derive the second, you're going to bring that second power down in front, subtract 1 from the exponent, and then you multiply by the derivative of the inside function, which is y prime. Okay? So then, on the right-hand side, we just have the function 1. That derives to equal 0. So that's the derivative step. We just derived everything in sight. So now, what we want to do is we want to get this y prime by itself. So figure out what terms have a y prime in them and keep them on the left-hand side. So it's this one and this one. Everything else gets moved to the right-hand side by subtraction or addition. So this is all the red underlined stuff is getting moved to the right. All the yellow underlined stuff is going to stay on the left. Does that make sense? I wish I could hear your answer. Okay, so we're going to subtract from both sides all the red stuff. So minus 3x squared. We'll add on a 2y, and we'll subtract away a 2xy squared. We'll do that from both sides. So we have minus 3x squared plus 2y minus 2xy squared. Try to squeeze it all in there. You'll see it in the next step. So we have so the stuff that remains is minus 2xy prime from this. Tack on a x squared times 2 times y prime from this guy, and then everything else is on the right-hand side. So what does that give me? That gives me minus 3x squared from the first term plus 2y minus 2xy squared, all on the right-hand side. So now notice, on the left-hand side, all we have is our y prime terms. All the stuff on the right-hand side is going to have no y prime terms. So final step of this computation is, penultimate step, factor out the y prime on the left-hand side. So that gives us y prime minus 2x plus x squared times 2 times y. And this is equal to everything that is on the right-hand side of this lovely equation. Okay. Now, final step. Divide both sides by this nasty set of parentheses on the left. And this will get you your y prime by yourself. You're probably seeing a pattern by now. Yes, it works the exact same way every single time. I promise. So, doing that, skipping the showing of the division, I have minus 3x squared plus 2y minus 2xy squared all over the lovely set of parentheses that we had on the left. Yes, I could rearrange these terms. No, I don't care. and your teacher's probably not going to care either. So that's the answer. That's how you do this one. It's just a lot of product rule and just complicating the derivatives, but the method is still exactly the same. All right, so that's example number 7.